So here's my definition, and here's what we mean by data analytics in the Cambridge Master of Accounting program. I define it as using data and computational techniques to generate and answer relevant questions and or to automate or improve tasks and decisions. And our goal is to train sophisticated leaders and consumers of data analytics. And so we're sort of in the middle here with regard to technical detail. So we provide a little bit more than an executive program or typical MBA, but we're not training full-time data scientists. I'd like to just go into a little bit more detail about 3 of our modules around data analytics. And the first one I want to start with is called Descriptive Analytics. And this is essentially using analytics techniques to try to describe something, describe the way the world looks. And our focus in this module is data visualization. So let me give you a little example here of a really old data visualization that illustrates the power of this technique to have a real impact. So this is John Snow. John Snow was an English gentleman living in London in the 1800s. He was a physician. And he had a question. There was a rather urgent question facing London at that time. In the Soho area of London, there was an outbreak of cholera. And at the time, people believed that cholera was caused by inhaling decaying organic matter. So like bad air is what they called it. And they believed that that is what caused people to die of cholera. Dr. Snow wasn't sure about this and thought that there might be an alternative explanation for why people get cholera. So that was his question. Why are people getting cholera? So he prepared some data. He went out and gathered data, and so he canvassed the area of Soho, going around to people's homes and trying to really just asking, have there been any cholera infections in your home? So he went all over the Soho area. This is a map of Soho at the time. This is Broad Street. If you can't see the letters there, but this is Broad Street right here. And his method of analysis was a data visualization. So he simply plotted cholera cases on the map of Soho. And here's what he ended up with. So the black dots that you can see around here are cholera cases in the area. Now, right around the center of the map, right here, you can see a little cluster of dots. Okay, so the interpretation here and the analysis is maybe something is going on in this area. So Snow went back to this area and he did gathered some more data by asking some questions about the activities of the people around this cluster of cases. And he found that all of these cases, the infected people had consumed water from the Broad Street pump, the Broad Street water pump. So in this time in London, to get your water, you took your bucket or container, whatever, to the pump, the local pump, and you pumped it out and then you took it home. So all these infected cases had come from this single pump. So what's the interpretation here? Maybe there's a causal relationship between water or consumption of water that's contaminated and cholera. Now, you could do a much more sort of rigorous study, right? And by today's epidemiological standards, this is crude. We prefer sort of a randomized controlled trial, but it still got the job done because the action that was taken was simply to remove the handle from the Broad Street pump. That's it. 5-minute job with a spanner or a wrench, right? Remove the Broad Street pump handle. Now no one can use it. And what happened to the cholera cases? They went to 0 in the area. So what had actually happened was there was a sewage drain right next to the Broad Street pump, and there was contamination between the sewage and the drinking water. And that was causing the cholera outbreak in London. So today there's, if you go to Soho today, there's a pub called the John Snow Pub, and there's little monument to John Snow, one of the sort of pioneers of epidemiology studies, and the pump with no handle is the monument to John Snow. So the point here is data visualization can be a really powerful analytics tool, and it has been in the past. So there was no regression here, there was no machine learning, there was no AI. This was a picture that had a real impact. Okay, so when we talk about data visualization, we approach it from two different angles. The first one is exploratory. So data visualization can be useful for just understanding a data set. So you may have a set of transactions, or you may have a set of survey data, and you're just looking to understand what's going on in this data set. What are some potential relationships? And so you're just exploring the data set. So that's one part of data visualization. Then there's what we call explanatory data visualization. And this is, well, now I've seen something in my data. I've seen some relationship or some trend or some pattern, and now I would like to communicate that. So I would like to, now I'm moving into the persuasion area, right? So I'm trying to make some kind of argument or some kind of case. This is quite a different task, and it involves understanding who you're communicating with and what their potential objections might be, and how can we communicate effectively and quickly what we're trying to say to make our argument. And so this is where we go into what makes a good visualization, and alternatively, what makes a bad visualization. So there are lots of examples that we can draw on here from the world of good and bad visualization. Here's a particularly bad one from the 2012 presidential election in the United States. So you can probably see what's wrong with this if you look. So these three surnames, Huckabee, Romney, and Palin, were candidates in the 2012 presidential election. If you look at the numbers here, they don't add up to 100%. So in a pie chart, we're looking at a whole relationship. All the parts should add up to 100%. So this is an example of a really bad visualization. Here's an example of what, in my opinion, is a good visualization. Now, we'll talk in this module about what exactly we mean by a good visualization. But the audience for this is really just people, consumers, readers of this publication at the beginning of the COVID-19 outbreak. And the purpose of this visualization was intended to explain quickly what epidemiologists meant by flattening the curve. Okay, so this is just back when we were talking about what do we do about these outbreaks and why do we need to do it. And so you can see that it's a sort of a minimalist look to this chart. There's two curves here. There's one that's colored in red and one that's colored in gray. The axes are clearly labeled. So we have time along the x-axis, and we have daily number of cases on the y-axis. And you can see here that we have these two curves, okay? One is cases without protective measures, and the smaller, the flatter curve is cases with protective measures. So this is trying to communicate what happens if we do nothing and what happens if we do something. And it spreads out the amount of time that the outbreak takes. It reduces the overall number of infections, and then this dashed line right here, healthcare system capacity, is the whole point, that we're trying to avoid overloading the healthcare system. So I think this is a pretty good, in my opinion, visualization, because it contains just the elements it needs to communicate a story effectively to its audience of readers. Okay, its purpose is to try to get someone to wear a mask, wash their hands, and understand why. So in the Cambridge Master of Accounting, we do a lot of work in Tableau, which is a really powerful data visualization tool. There are other tools out there, and your organization might use something like Microsoft Power BI or something like that. These tools have similar goals and similar sets of capabilities. Tableau is essentially a visual query language, so you can take your data set and really quickly build things like heat maps and geographical analysis and bar charts, pie charts, and really easily implement color and implement size and other data encoding mechanisms. To build really nice looking visuals. So Tableau is really useful for both exploratory and explanatory data visualization. So our module around predictive analytics looks like this. This module will introduce you to predictive analytics. You will learn where to get the large data sets needed to power your machine learning algorithms and some examples of innovative companies already deploying predictive analytics. Then you will learn the intuition of 4 classes of machine learning algorithms: regression, trees, support vector machines, and neural networks. We saw all of those on the previous slide. You will also practice using these algorithms in Python. Finally, we will cover perennial issues in data analytics, how to deploy predictive algorithms ethically, and how to get an organization culturally ready to be data-driven. So here is where we explore these machine learning algorithms in a level of detail where you're actually running some code. So you're actually learning Python, which is a really popularly used general purpose programming language with a lot of really nice data science libraries. Libraries are just code that's out there and all ready for you to run. So you're going to be writing some of this code to implement these predictive analytics algorithms. Analytics applications is another module, and here is where we bring in some other technologies that aren't necessarily related to answering a question with a data set, but more around automating or improving some kind of task or decision. So blockchain, for example. Blockchain has actually been around. The algorithm has been around for a long time, about a decade or so. And it's kind of this thing where we're not quite exactly sure if this is overhyped or if there's real promise around blockchain. So we'll go into some detail about the technology underlying blockchain, what it actually is, what it will or might do, and what it won't do. This could have some serious implications for accounting, for audit, for supply chain, for financial transactions, but we'll understand better what it is and what the current state of implementation is. We'll talk about the state of the art around machine learning and AI applications. So some more detail on what firms are actually investing in, how do they make these investing decisions, what's the return on these investing decisions, and how to think about that strategically and ethically and from a policy matter. Okay, so we'll explore through case studies and guest speakers all of these bigger picture issues. So in addition to gaining some understanding of these algorithms and actually implementing them, we're going to step back and think about this from a leadership perspective.